Hello, my name is Michael Johnson. I'm a student at Texas A&M University, and today I wanted to talk about Opendtect, which is a software that is free. It's open source, and the purpose of the software is seismic interpretation for both 2D and 3D. Um, so Right here is a description of Opendtect. It's a complete open source seismic interpretation package widely used in the industry. So that means oil and gas industry and also the GIS industry. And how it contains the tools needed for 2D and 3D seismic interpretation. These are some of the functions that it does. I'll go over these, a few of these right now that may not be listed on this page. And they include geo-radar interpretation, pre-stack viewers, seismic attribute analyses, time depth conversion, fault interpretation, geobodies, depth conversion, well type functionality, horizon trackers, and 2D and 3D viewers. So that's some of the key features for Opendtect. But to generally explain what it does is just imagine a big company such as BP that wants to drill down and find the resources such as oil and gas, and they don't want to blindly just drill everywhere. So what do? They gather geotechnical data, geoseismic data, and then this is the type of software that people use to interpret those results and find those pockets. And what it's really about is petroleum exploration. All right, and so this software allows people to be able to visualize the reservoir imaging and extract the maximum information from the seismic data. So this is the free software, and the software that's available for educational purposes, but there's also closed sourced, not free data through that they offer, such as Opendtect Pro, and they have extendable plugins as well that extend the capabilities. This software is available because of this company right here, DGB Earth Sciences, which since 1995 they've been offering the leading edge seismic interpretation software solutions around the globe. I wanted to point out that I see a quote here from Dr. William Bryant of Texas A&M University. He's part of the Department of Oceanography and the faculty of graduate students within the department, and he says he deeply appreciates the use of such a valuable tool. So I downloaded the demonstration package that they offer, the tutorial that Opendtect offers. And so today what I want to do is open up DTEC, the software, and then start a new survey, and then import the segue data. The segue data is right here. This is the part of the tutorial. It says it is the industry standard seismic data format that was defined originally as a tape format. It consists of EBCIDIC header with general information like data format, trace length, and sample rate, followed by a binary header, which is the descriptive data typed in by the seismic processor, and seismic traces. Each trace consists of two parts: a trace header followed by a trace data. And then down here it talks about Opendtect can work directly on segue data files. Okay. Alright, so I'm going to minus this down, minimize that, and then here is the Opendtect version 6.2. And alright, so up here at the top left, this is the survey. We click on, so to start a new survey, let me point out first that it's something that took me some time to figure out is under select and setup. You want to make sure that you click here on survey data route, and you want to point it towards where you've got this file stored, to the Opendtect data root directory. That's important. And if you clicked on select here, then you can point it to the directory, the data root directory that is proper. So that's important, and then it'll show it right here. See, open says Opendtect data root. I think I just misspelled that. All right, so let me close this. All right, survey. Yeah, so we wanted to click on that again. All right, so it's opened up here to this screen. So I've got these that I've already been working on, and right here in the middle is create a new survey. So that's what I want to do. We'll click on this license finder right here. That's popping up because I also downloaded the Opendtect Pro for educational purposes, and so it's looking for the license. But it won't ask you that if you just pull the basic free version, open source version. So now it wants us to name the survey. This is the create new survey screen. So right here we click on, we'll call it the MJJ new demo survey 2. Now let me pause right here and go back. I want to tie this into something I forgot to say earlier is, so how does this all tie into geographic information systems, GIS, which is pretty much the bulk of what I'm studying at the university. And so what is GIS? It's a tool. It really is. What it comes down to is just it's a tool that we use to manage and analyze and display spatial information and visualize it on computers, right? And so that's how this ties into GIS, because that's what GIS is really all about. I mean, it is exactly what this software is used for, is visualizing spatial information. So, all right, so we pulled up the create new survey window, and we've named it. That's my initials there, so I just kind of named it what I want. And right here, we're going to, under initial setup, we're going to scan SegWi files, and we're choosing Z domain time, and we click next. All right. So now we have to point it towards where's this SegWi file, and I have this under the demo training and raw data, and there it is, seismic data s.sgy. We're going to open that. Alright, and it pulls up this information. So this icon right here with the blue arrows, I've already scanned it. See, that's why I pulled it up already. That's going to scan the traces of this SegWi data. It'll just take a minute. Alright, 95%, and it's there. Okay. Alright, and if we go back, I see I've kept this tutorial open because if we go back and look and see, it kind of talks us through what I just did. And the reason why I pull this up to show you that this is an import wizard. It can make a quick scan of the SegWi volume and automatically fills in relevant parameters for survey setup and import. This bottom part here shows the extracted geometry of the survey and the histogram of seismic amplitudes from the quick scan of input SegWi volume. Alright, so let me go back to, let's minus this down. I'm going to go back to the software, and so what we're going to do, we scanned it. Now I'm going to click on this magnifying glass icon, and this is the SegWi examiner, so we can see the file header information here. It shows the X coordinate, the Y coordinate, inline information, the X line information here. Alright, and you click right here, and there's the viewer, so we can see it. Okay, the information. We have the option where we can save that, and we click OK. I think we're ready to do that. Alright, so what we did right there was we just examined the seg-y data and made sure it looked right and correct, and then now we are preparing or editing any survey parameters. Okay, this right here, you can make you can reduce this range and for quicker processing if you don't need that full range. Alright, so everything is fine right now. We'll click OK, and let's see if this works right here. We'll click select, and it asks you, do you want to import? So now that we've already examined it and then created the parameters, yes, we are ready to import the seg-y data. And now it wants us to let's see what we're copy data. We'll leave that as a yes, and we'll make this seismic data 4. This is the output cube name, and we click OK, and now it's importing the seg-y data. This takes less than a minute. Alright, it says the cube is available for work. The cube has varying cross-line ranges. Here's the inline range, the x-line range, and the z-start number of samples and gaps are present, which is normal. This is the z-scaling. Z-scaling, we can change the depth of this frame. Right here I like to just click on fit to scene. Alright, that didn't do exactly what I wanted it to do here. Let's see. Alright. I don't know why that. There we go. And that'll work right about there, and click OK. Now, then the next step is we can go over here to the scene 1 under inline, right click and add default data. Left click on that. And that's just saying that no saved color settings were found for the selected cube. Default settings will be loaded. OK. Alright, so here's seismic data 4, which is what I named it as the output, right? That's seg-y data. Alright, so we select that, and up here we can change the colors. See right here it was already on seismics, and we can go, like, for instance, to magic, or to let's see, just whatever we want. Grayscales. And then, I mean, you can just change the way you're visualizing this information here, this data. Tasty. Okay, let's go back here. Okay, magic. Alright. Alright, so now I want to go through a couple of other things we can do. And then I'll talk about what we've accomplished here. So for this data, a couple of things we can do is on the mouse right here, if you make sure that this green arrow is selected and you click on the frame here, and then see how these green little squares on the edges, you can readjust. As long as you've got this green arrow selected and it shows these green squares, you can click and you can adjust the size of what you're looking at. And that'll come into play later when you're doing your adjustments, and maybe you want to focus on a certain little area of this, and so maybe this is the part you want to focus on, so you can bring it down to right here, right? Also on over here on the left, right there, this symbol right here is a view symbol. You click this arrow, this drop down menu next to it, and you can choose view inline, or you want to view north, or I guess we're already viewing north Z. Alright, now on the mouse, if you have a mouse similar to the one that I'm using, it has a roller in the center, and you can roll it up and down like this, and it'll bring it closer or further away, and then the image. And then if you click and hold down on that roller in the center, and then you can move the image around, okay, with the touchpad, and then you let go. Now if you press and hold shift and then press down and hold that roller, and then you can, with the touchpad, you can view. You gotta release and do it again, and you can view this whole thing. You can move it around any way you want. And okay. So I wanted to I want to show you just an example of see how this is. You can just keep it going in space like it was kryptonite in space, moving around. So that's pretty cool. So an example. Let me see if I can even get to. Okay. All right. Survey, and I can click on survey, manage. See if I'm doing what we're doing here. Alright, so right here, another thing you do is you click on survey, manage, which is what I just did. You go down to seismics and then choose 3D, and right here it displays the inline information, so you can go through and double check that. It gives you all the information here: inline range, crossline range, area, square under, and it's measured in square kilometers. The time range, the storage, file name. Remember how I named it? Seismic data 4. Okay, and then all right, and now let's see if I can do this. Pull up. Okay, so what I did was I just chose. I'll let it finish what it's doing. I wanted to see if I could do it before I explain it. I just went to something we recently did for an exercise, so that I can just give an example of some of the things that you can do. I'm not one to go through. It would take a long time for me to go through every exercise that we went through, but I wanted to show that some of the capabilities once this is done processing here. Alright, so these are some simple samples of things that we were working with, and this is I'm going to hold down shift and I'm going to adjust this. So you see it in 3D. It's pretty amazing to watch. And then so you can change, there's a lot of pretty cool things you can do with this program, and even though I wasn't going to go over it completely, I wanted to just give you an idea of how amazing it is. Alright, and this was under the as you can see over here on the left where my mouse is, the 3D horizon. So we created an azimuth view and then also a polar dip view. See. Alright, here's an example of a sample inline, and you can move this thing all the way around here. Change it up like we talked about. Zoom way in. And this is an example of the seismic data that that an engineer for a company such as BP might be, or a GIS representative might be studying and analyzing. All right. Now, for surveys like this, let's say you want to save this data, so you can come back to it. So under sessions, go to survey, session, and save. And you can click OK, name it, overwrite. I'm going to go ahead and cancel it if I would click OK. So also if you go to survey, manage, and survey session and auto load, that if you save this, whenever you open it up, which I'll go ahead and say OK, it will automatically come up. This is a little default to you when you open it, whenever you open up the software. Okay, and that's it. I appreciate your time and you listening. Thank you very much. Let me, as soon as I have to wait on this to process, so I can close this down.